In this video, we're looking at Kirchhoff's current law. The law states that at any junction or point, the sum of all currents entering the junction must equal to the sum of all currents leaving that junction. For example, if we have this junction and we call this current I1 and we call this I2, we call this I3, and we call this I4. If we sum all of them, since the ones entering equals the ones leaving, it means if we sum the individual currents I1 plus I2 plus I3 plus I4, it will equal 0. So sum of the individual currents must equal 0. Why will it be equal 0? Assuming we assign a positive value for the current entering the junction and we assign a negative value for the current leaving the junction, then since both of them will be equal, they will cancel each other out. For example, if 5 is going in, we call him positive 5, and then negative 5 is going out. So it means that positive 5 minus negative 5 equals 0. So if we have, for example, this junction and I1 is going in, and let's say I2 is moving out, we call, let's say I1 equals, let's say 5 ampere, and I2, let's call him 3 ampere. Because it's leaving, we call him negative. Then I3, let's find I3. Then what we're going to do is say I1 plus I2 plus I3 equals 0. Now the value of this I3, if it's negative, it means that I3 is leaving the junction. If it's positive, it means I3 is entering the junction. So since I1 is positive 5 ampere plus I2 is negative 3, so we're going to say negative 3 ampere plus I3 equals 0. 5 minus 3 is going to give us 2, positive 2, plus I3 equals 0. If this 2 crosses over, it becomes negative. So we have that I3 equals negative 2. For the fact that it is negative means that it is actually leaving the junction. So if we check, the current entering the junction is positive 5 ampere. Now the current leaving negative 3. The I3 is negative 2. You notice that 5a, 3a, 2a, it will be equal to 0 because they will cancel out. Let's look at another example. At this junction, this is I1, maybe I2, I3, I4. Now you can notice that I1 plus I2 plus I3 plus I4 equals 0. Now, how do we get this I4? We know that this is leaving the junction, so it's negative 8. I2 is entering, so it is positive 6. I3 is entering, so it is positive 10. But we don't know I4, so we say plus I4 equals 0. Now, this and this is 16. 16 minus 8 gives us 8. So we have that 8 plus I4 equals 0. So if this 8 crosses over, it becomes negative. So I4 equals negative 8 ampere. So for the fact that it is negative means it was actually leaving the junction. If we check the current entering into the junction, the first one plus 6, the second one plus 10, this is leaving, so we say minus 8, and I4 is also minus 8, so minus 8. So this is 16, this is minus 16, so both of them equals 0. So let's look at this example. If we say this is I1, I2, I3, I4, and I5. Now this is, we note the arrows. Now we're to find I4. The question says evaluate the value of I if I3, if I4 equals 2I3. Also, we're also going to find them. Okay, Now, the first thing we do is to say that I1 plus I2 plus I3 plus I4 plus I5 equals 0, because the sum of all of them must equal 0. Now for I1, this is the direction, so positive 12 ampere. Now the second one is leaving, so negative 8 ampere. The third one is I4, and I4 is actually equal to plus 2I3. The next one is entering the circuit, so plus 20. So then plus I3 equals 0. 1, 2, 3, 4, 5, complete. So we're going to evaluate and collect like terms. If we evaluate this, and this, we're going to get here 8, and so this and this, 32 minus 8 gives us 24. So 24 plus I3, 2I3 plus 1I3 gives us 3I3 equals 0. Because of that, 3I3 will now give us negative 24. So since it's negative 24, it means it is actually, this is 3I3, that is negative 24. What we are now looking for is only I3. So only I3 will now be equal to negative 24 divided by 3, and which will give us negative 8 ampere. What it means that only I3 is negative I3. Now remember, for us to now evaluate I4, since that I4 is equal to 2I3, what it means is that I4 is equal to 2 times negative 8. So that is what it means, and I4 will give us negative 16 ampere. If we're to check the current that goes in, we will have 12. So 12. We will also have 20, which gives us 32. If we check the current that goes out, we'll have this 8, and then, so the first one, negative 8, the second one is also negative 8, I3, and then the fourth one is also negative 16. So this is already 16 plus another 16, so which will give us negative 32, negative 32 ampere. So you notice both of them, if you add them, equals 0.